Hello friends, so let us continue with the solution. So in the next question we have given that A1, A2 up to AN are in AP with the sixth term equals to 2, and if the product of A1, A4 and A5 to be maximum, we have to find out value of D. So this product we need to maximize, and for that we have to obtain the value of D. Okay, so very first thing we are going to do is to convert this three terms in form of D, and with the given condition, if A6 equals to 2, so we have A1 plus 5D equals 2, so we can obtain A1 as 2 minus 5D. We all know that A4 can be written as A1 plus 3D and A5 can be written as A1 plus 4D. So if I want to make a function of D which shows the multiplication of A1 dot A4 dot A5, so A1 is equals to 2 minus 5D, then A4 is equals to A1 plus 3D. In that A1 if I put as 2 minus 5D, so 2 minus 5D plus 3D, that is 2 minus 2D, and 2 minus 5D plus 4D, that is 2 minus D. So let's do the multiplication. So if multiplication I will do, then it is 4 minus 4 minus 10, that is minus 14D plus 10D square into 2 minus D. So f of D will be 8, then minus 28 minus 4, that is minus 32D, then plus D square plus 20D square, that is plus 34D square, and minus 10D cube. So this will be the function. Now for maximum or minimum value we need to do first derivative. So in first derivative it will be minus 32 plus 68D minus 30D square. If I take minus 2 common, so I will get 16 minus 34D plus 15D square. And if I want to make the factors of this, so its factor is 5D minus 8 and 3D minus 2. If you just check, 5 into 3, that is 15D square, minus 10D minus 24D, that is minus 34D, and minus minus plus 16. Right? Now for getting maximum and minimum, let's go with the first derivative test. And in first derivative test, let's find out the critical point. So we have two critical points. First critical point is 2 by 3, and for second critical point it will be 8 by 5. So on the left side of 2 by 3, this two function will give us negative answer. So negative, negative, positive. With negative, so answer will be negative. And now from the Vivico method, if it is negative, then compulsory in the next interval it will be positive, and in third interval it will be negative. Now according to the first derivative test, in the interval where derivative has minus answer, function will be decreasing. So in between minus infinite to 2 by 3, this function f of t will be decreasing. Maybe the graph something we don't know exactly the graph, but we'll just plot a simple condition, decreasing. Then in between 2 by 3 to 8 by 5 again increasing, and then from 8 by 5 to infinite it will be decreasing. So at the point 8 by 5, this function gives us maximum answer. Therefore D has answer 8 by 5 to maximize f of D. Right? You can also go with the second derivative, right? But in that first you do second derivative, then you have to put these two critical points one after another, and then we have to check for the less than and greater than 0 condition. Apart from that, this will be the less time consuming, right? So this will be your answer. Let's talk about next question. Okay. In next question, we have given that line drawn are parallel to the line. If we have a line 4x minus 3y plus 2 equals 0, right? We have to plot a line which are parallel to this at a distance 3 by 5 from the origin, right? So let's take a line parallel to above line. Parallel line, if I want to write down, so parallel line can be 4x minus 3y plus k equals 0. Now this line has a distance 3 by 5 from origin, then which one of the following point lie on these lines, right? So what we'll do first, we will first find out value of k, and then after getting value of k from 4 options, we are going to satisfy the points which are on the lines, right? So the first condition, I just find out the line parallel to the given line, which is 4x minus 3y plus k equals 0. Let's go with the distance formula. We know that distance between point and a line can be written as ax1 plus by1 plus c by root of a square plus b square. According to this, the distance is given as 3 by 5, a that is 4 into x1 which is 0 plus b that is minus 3, y1 which is 0 plus k upon root of a square plus b square, that is 4 square plus 3 square. So 3 by 5 equals to mod of k, because 0 and 0 will be cancelled, and 4 square 5 and 3 square 16, 9, 25, root 25 which is 5. So mod of k equals 3. Therefore k will be plus or minus 3. Therefore the required line is x minus 3y plus 3 equals to 0, or 4x minus 3y minus 3 equals 0. And now by using trial and error method, from the given 4 options we have to satisfy the point. So from the given option, the point minus 1 by 4 and 2 by 3 will be your answer, and which will be satisfied by this line. You can just put the point to cross verify the answer. If you put minus 1 by 4, so 4 cancel minus 1, 2 by 3, 3 cancel minus 2, minus 1 minus 2 that is minus 3, plus 3 gives you answer 0. Right? So that is your answer. Then next question, if we talk about, okay, so in next question, we have given one equation, that the equation is 5 plus 2 raised to x minus 1 equals 2 raised to x into 2 raised to x minus 1. We have to find out the number of real roots. We have to find out the solution of this question. Right? So to get the solution of this question, first we have to focus on this modulus. So first case, this term equals to 0 has answer 0 at x equals 0. So let's find out that what if I put x equals 0. So for x equals 0, let LHS. The left side will be 5, because 2 raised to x 0, 2 raised to 0, 1 minus 1 0. So left side answer is 5, and right side answer, if I want to find out, then 2 raised to 0 1, 2 raised to 0 1 minus 2 equals minus 1, hence LHS is not equals to RHS. Therefore x equals 0 is not the solution. Now let's talk about second condition, where x has answer less than 0. So if x will be less 0, then this particular term has negative answer. So the equation will be 5 minus 2 raised to x plus 1 equals 2 raised to x plus x 2x, and minus 2 into 2 raised to x. So 2 raised to 2x, if we take this on the opposite side, then it will be minus 2 into 2x plus 2 raised to x, that is minus 2 raised to x, and minus 6 equals 0. So this can be the quadratic equation in form of 2 raised to x. So its factor will be 2 raised to x minus 3 and 2 raised to x plus 2 equals 0. So 2 raised to x equals 3, or 2 raised to x equals minus 2. Now 2 raised to x equals minus 2 not possible, right? And 2 raised to x equals 3. So from this we can get x as log 3 with base 2. But the condition of x we assumed as x less than 0, and log 2 base with log 3 with base 2 has positive answer. So this 2 is not similar to each other, right? So this is not the solution. This is not solution. So let's talk about the third condition. In third condition, let's take x greater than 0. So for x greater than 0, modulus will be the positive one. So 5 plus 2 raised to x minus 1 equals 2 raised to 2x minus 2 into 2 raised to x. So now it will be 2 raised to 2x minus 3 into 2 raised to x, and minus 4 equals 0. So now the factors are 2 raised to x minus 4 and 2 raised to x plus 1 equals to 0. So now 2 raised to x equals 4 and 2 raised to x equals minus 1. This again not possible, right? This is not possible. So 2 raised to x equals 2 square, hence x equals 2. And as the condition of x we have assumed already, which is greater than 0, and 2 is also greater than 0. So this will be your solution. Okay, let's talk about next question. In next question we have given a line y equals minus ax plus c, and it will touches both the curves. Y square equals 4 root 2x and x square plus y square equals 1. So we have to find out value of mod c. Okay, so one of the lines given to you, and this line is a common tangent of parabola and the circle, right? So very first thing, before we can start the question, you need to know that any line y equals mx plus c be the tangent of y square equals 4ax and x square plus y square equals r square, as condition c equals a by m or c square equals r square into 1 plus m square, right? The same line with a tangent for parabola as well as circle as these two conditions, right? So from given question, let's obtain the following conditions. So capital M has equals to answer minus a. If we compare 4 capital A with 4 root 2, so we'll get a as root 2, right? And the radius is equals to 1 and c will be as it is c. So first of all, let's go with c equals a which is root 2 by m as minus a. And then if I put the value in this, r c square equals r square into 1 plus m square. So c square equals 2 by a square equals r square. R has answer 1. So 1 into 1 plus m square and m has value minus a, it will be a square. So it's 2 equals a square plus a raised to 4. So we'll get a raised to 4 plus a square minus 2 equals 0. So factors will be a square plus 2, a square minus 1 equals 0. So a square equals minus 2 or a square equals 1. So a square equals minus 2 is not possible. So therefore a equals plus or minus 1 is the answer. And if a equals plus or minus 1, then c will be, mod c will be mod of root 2 by a. So mod c will be root 2 because a has answer plus or minus 1. Okay, so in next question we have given that limit x tends to 1, x square minus ax plus b upon x minus 1 equals to 5. And for this we have to find out value of a plus b. Now for any function, if the limit exists, then the very first condition we have to satisfy is 0 by 0. Because if I put x tends to 1 in the denominator, I'll get answer as 0. So compulsory, according to the existence of a limit, numerator must get answer equals to 0 for x equals 1. So at x equals 1, numerator, that is 1 minus a plus b. If I put x equals 1, so 1 minus a into 1, that is a plus b, must be 0. So this is the first equation we'll get, 1 plus b equals to a. Now let's go with the L'Hopital rule. Do the derivative in numerator and do the derivative in denominator. So limit x tends to 1, x square as derivative 2x minus a upon 1 equals 5. So now if you put x equals 1, so it's 2 minus a equals 5 and a equals minus 3. And for the value of x equals minus a, b will be minus 4. And now if you want to find out a plus b, so minus 4 minus 3, which is minus 10. So is even just you need to keep this point in your mind, that for the existence of a limit, if denominator as answer tends to 0, numerator must be in form equals to 0. That is the 0 by 0 form of the limit. Okay, in next question we have the distance of a point having position vector, let's say the point is P of -1, 2 and 6, from the line passing through the point, let's say A bar equals 2, 3, -4, and having the direction parallel to the vector, that is L bar given as 6, 3, -4. Okay, so we have to find out the distance between a point and a line. So if I say that this is the line with the direction vector L bar and the point A bar from where the line is passing, and there is another point which is P, right, P bar. So we have to find out this perpendicular distance first of all. Okay, so first of all let us assume that there is a point M which is on the line. So first of all, equation of a line, that is R bar equals A bar plus KL bar. So R bar equals A bar 2, 3, -4 plus K 6, 3, -4. So coordinates of M can be 2 plus 6K, 3 plus 3K and -4 -4K. So vector direction will be PM. So vector PM will be 2 plus 6K minus, here it is -1, 2 and 6. So 2 plus 6K minus plus 2, so it's 3 plus 6K. Then 3 plus 3K minus 2, that is 1 plus 3K. And -4 -4K minus 6, that is -10 -4K. Now we know that PM is perpendicular to L bar. So 3 plus 6K, 1 plus 3K and -10 -4K dot L bar, 6, 3 -4 equals to 0. So let's find out value of K. So it will be 18 plus 36K plus 3 plus 9K and plus 40 plus 16K equals 0. So from that it's 36 plus 9, 45, 45 plus 16, that is 61. So it's 61K. Then 40 plus 18, 50 plus 1, 61 will get equals 0. Will get K equals -1, and then for K equals -1, vector PM will be, so PM will be 3 minus 6, that is -3, 1 minus 3 -2, and -10 plus 4, that is -6. So the distance is nothing but the magnitude of vector PM, which is 9 plus 4 plus 36, that is √49 equals 7. So that will be your answer. Right? You can also go with the formula between the distance, formula of a distance between line and point, which is given in your textbook also. So that is the another method. Right? Let's talk about next question. So in next question, we have given that mean and standard deviation of observation. We have given 50 observations, x1, x2 up to 50. So n equals 50 observations, and the mean and standard deviation of those 50 observations are given as 16 itself. So x bar equals 16 and s is also equals to 16. Both are equal. So we have to find out mean of x1 minus 40 whole square, x2 minus 40 whole square, right? Sorry, not 40, it's 4. x1 minus 4, x2 minus 4, x3 minus 4 whole square, dot up to x50 minus 4 whole square. We have to find out mean of this. Now if you want mean of them, so it will be sum of those terms by number of observations. Now there is a rule from this statistics chapter that mean can be changed if we multiply, divide, add or subtract, right? It will be affected by all four operations, and standard deviation can also only affected by multiplication or division. That means if the 50 observation has x bar equals 16, and if I subtract 4 from all the observation, then new mean will become 16 minus 4. So here the mean of x1 minus 4, x2 minus 4, x3 minus 4 dot up to x50 minus 4. I am just talking about the mean of the terms without square, right? So mean of x1 minus 4, x2 minus 4 is equals to x bar dash equals x bar minus 4. So x bar dash equals 12 because old mean is 16, right? And the standard deviation of these observations will not be changed because s dash equals to s equals 16. Now if I talk about the standard deviation of those terms, so it can be written as root of sum of xi minus 4 whole square by n minus new mean x bar dash with square. This is the following equation for the new observations, right? And this thing we need to find out. This we want to find out because it's a mean of this term, right? So s dash equals to given as 16 root of this x1 minus 4 whole square plus x2 minus 4 whole square up to x50 minus 4 whole square by 50, which we want to find out, and minus 144 because the square of new mean, which is square of 12. Okay, now if I do the square on both the side, let us say that x bar double dash, this can be x bar double dash. Okay, let's say square, that is 256 equals x bar double dash minus 144. So x bar double dash equals to 256 plus 144, that is 0, 0 and 400. 4, that is 400 is your answer. As I told you that okay, so next question. So in next question we have given that cos inverse x minus cos inverse y by 2 equals a for x belongs to minus 1 to 1 and y belongs to minus 2 to 2, and x as less than or equals to y by 2 condition. So we have to find out value of 4x square minus 4xy cos a plus y square equals dash. This we want to find out. So let us assume that cos inverse x as alpha and cos inverse y by 2 as beta. So x will be cos alpha and y by 2 will be cos beta. So what if I say sin alpha? 1 minus x square, and sin beta will be 1 minus y square by 4. Let's put the values. So now it's alpha minus beta equals a. Apply cos on both the side. So cos alpha cos beta plus sin alpha sin beta equals to cos a. Cos alpha has value x, cos beta has value y by 2 plus 1 minus x square 1 minus y square by 4 equals cos a. Take xy by 2 on the opposite side. So 1 minus x square dot 1 minus y square by 4 equals cos a minus xy by 2. Now squaring both the sides, squaring on both the sides, we'll get 1 minus x square into 1 minus y square by 4 equals cos square a minus 2 times cos a xy by 2, which is minus xy cos a, and plus x square y square by 4. So now multiply on left side, so we'll get 1 minus x square minus y square by 4 plus x square y square by 4 equals cos square a minus xy cos a plus x square y square by 4. So we can cancel out x square y square by 4 from both the side, and let's take this term on the opposite side. So 1 cos square on the opposite side, so minus cos square equals x square minus xy cos a plus y square by 4, and if you take an LCM, this will become sin square a for multiplication with 4. So 4 sin square a equals 4x square minus 4xy cos a plus y square. This is your answer. Right? This is your answer. Okay. In next question we have three equations given to us. X plus y plus z equals 6. Then 4x plus lambda y minus lambda z equals lambda minus 2, and 3x plus 2y minus 4z equals minus 5. If this linear equation has infinitely many solutions, then we have to find out the value of lambda, and one of the quadratic equation is given to us in the option. So we have to verify that value of lambda will be the root of one of the following quadratic equations which are given in the option. So first let us find out the value of lambda. So if the solution has system has infinite many solutions, so its determinant will be 0 directly. So 1 1 1 4 lambda minus lambda and 3 2 minus 4 equals to 0. So let's find out the value of lambda. So it's 1 into minus 4 lambda plus 2 lambda minus 1 into minus 16 plus 3 lambda and plus 1 into 8 minus 3 lambda equals to 0. So it's minus 2 lambda plus 16 minus 3 lambda and plus 8 minus 3 lambda equals to 0. So it's minus 8 lambda plus 24 equals 0, hence lambda equals 3. And now if I talk about 4 options, so the options are option A, lambda square minus lambda minus 6 equals 0. Option B, lambda square minus 3 lambda minus 4 equals 0. Option C, lambda square plus 3 lambda minus 4 equals 0. And option D, it's lambda square plus lambda minus 6 equals 0. So we have to check that which one of the following quadratic equation has root lambda equals 3. So it's compulsory option number A. Option A is the root as lambda equals 3. Okay, so this option A is your answer.